Hello, everyone. Welcome to the recap stream for the 2022 Wheel Reinvention Jam. We are so excited to finally be doing this about a week after the jam has wrapped now. We've had a great time over the past week looking at all of the project submissions and, deciding what we wanted to showcase here. We had an incredible turnout for this year's jam. We had 28 projects submitted by 35 different authors collectively, which is easily the biggest jam that we've ever done. Today, we're going to have a mix of some demo videos recorded by the project authors, as well as interviews with several of these project authors. So before we get into that, I want to take the time to introduce the admin team properly for those who may not know us. I'm Ben Visnes. I'm the Handmade Network lead.
Hey, I'm Asaf.
I'm Colin. You might know me as Gloin.
So this jam was an amazing time for all of us. Colin and I, in fact, directly participated and had the opportunity to make a project alongside of the rest of you. I absolutely love the opportunity to focus on just a single project, a small project for a week. I hope you all did as well. And I don't know, Colin, is there, any thoughts that you have sort of holistically about this jam?
I really enjoyed it. It's a nice opportunity to kind of get my fingers into something a little bit more short scope. I haven't done a jam in a while. We had a lot of entries too, and a lot of good stuff. I was super excited to see. We had 5 or 6 solid, big projects and a ton of little ones with some merit too. I don't know. It was great.
Yeah. How about you, Asaf?
It was really amazing to see all the activity in the Jam channel throughout the entire week and the showcase. It was really cool.
Yeah, I completely agree. It was, we had the whole project showcase set up this year, and people being able to really actively share what they were working on just gave so much life to the whole process. So anyway, since we started a few minutes late, I think it's time to get things going. We're going to first jump into an interview with one of the authors of the project SDF Atlas. This was a project by BYP and Skytrius. We have BYP with us today. So we'll get him in here. Welcome to the show.
Oh, hello.
So you, I understand, are going to demo this SDF thing for us. And I'd love if you could just give us the rundown on sort of, for viewers who might not be aware, what SDFs are and why this tool might be such a useful thing.
Yeah, sure. So an SDF is a signed distance field or a signed distance function. Basically, it's a function that, given a position, it reports back the distance to a boundary. And if it's a positive distance, you're on the outside of the boundary. And if it's a negative distance, you're on the inside of a boundary. So if you were rendering, you would color in the pixels that have negative distances, and then you would refuse to color the pixels that have a positive distance. And the thing is, I haven't said anything about the geometry that you'd pass, like how do you triangulate, because you don't triangulate. You just pass down an area, and then you just give it all the positions. So you can make pretty interesting shapes, and you can manipulate the sampling to get some interesting transformations, which I'll show there.
All right.
So,
Ooh, one moment. I'm sorry.
Here, yep. So here is the editor of the SDFs. So, other thing I forgot to mention is that typically SDFs you would write out like GLSL or HLSL, like shader language code, and then you would put in the functions there, and that can be productive and all, but sometimes it's really hard if you just want to visually point, click, and just drag things around, as opposed to looking at the numbers, looking at the functions, and manipulating them there. So that's a big part of what this Jam project is trying to solve. Just click, drag, you get a control point, you manipulate it, things like that. So here's the editor. You can do things like rounding out a shape.
Nice.
You can, scale them, rotate them, whatever you want. And then I mentioned that you could transform the sampling point. So basically, because we're only talking about positions, there's nothing stopping you from translating the position from a point that isn't going to report a negative distance to a point that is. So if you have a reflection, basically all these points on the red half of the line just get reflected over the line to a point that is going to be sampled as negative, and then it gets rendered on the screen. So you can have reflections like that, or instead of reflecting across the line, you can make a grid pattern, just take the index and sample them backwards, and then you can get a grid and then get just infinite repetitions like that. Or instead of doing it in a grid-like fashion, you could do it in a angular fashion. And so then you can have this sort of like angular repetition here. And then you can, increase the count of those angles. Yeah. And so I guess from there, there's also some other things. So you notice that we're doing like outlining of these shapes, and that's basically you just take the distance and then however much you want to outline by, you color a different color, or you can lerp it, and then you can modify that here. Yeah. And so from here, this is just like constructing these shapes. So let's construct something like, we'll put some triangles down. We'll put like a square, blow it up. Oh, let's get it fit, round it out a bit.
Can I say I love how fluid the controls are, and I'm curious what those controls actually look like, because it's like it's not obvious to me like how you're doing that, but it's extremely fluid.
Lots of scroll wheel. It's actually very unfortunate what these controls are, but that's because it's to support undo redo. So because we want clear undo redo boundaries, you have to click, and then that begins an undo boundary, and then you have to maintain clicking while scrolling. And then
Okay,
when you
all right.
release it, yeah, it's something. Very big downside in my opinion, but it was what we had to do. So yeah, we can just, make, oh yeah, this is like a second entry. So you can see at that top left there. So we'll just make another.
A second entry. Can you talk more about that? What do the two bars along the top mean?
Yeah, so these are the Atlas entries. You can make multiple SDFs in the same Atlas, and then the Atlas gets submitted to the GPU, which you can then indirectly index from CPU side code when you submit the render commands. So we have these two entries here. Then we'll switch over to, we'll switch over to a timeline. And now here we can see those two entries that we have selected there. We can give it, like, say, a color, drag it over into the timeline. And then for this one, we'll give it some other color, drag it over, and then we'll hit play. And then we'll lerp the distances between the entries as we render, right? And so we can just adjust those, move them around. And then not only can we lerp distances and just, play with them there, the other thing about like atlases is typically if you have like a texture atlas where you would indirect the texture bind or the texture sample, you can just indirect the atlas sampling, and then you can make this SDF Atlas. Similarly, you can do like, say, a particle system. So pretty basic particle system with nice little bouncing and restitution, but you'll maybe, if you squint, you can notice that it's also lerping the distances and the colors as well. Just fun thing you can throw together in like 100 lines of code or so. Yeah, and so this is doing it very much like CPU side. We just wrote like a particle system that you can plug and play. But then we can also do this very much GPU centric, where instead of having a lot of CPU code, we can just write HLSL code, which also uses the exact same texture atlas data. And that would become this like weird lava lamp sort of effect, where we're actually smoothly combining the boundaries of these distance functions. And then inside the code, we take basically the amount of negativeness is like the density of the color ramping that we're doing here.
Huh. And now this is in fact based on the shape that you had drawn earlier.
Yes, this is actually, and I can make it a little bit more clear. I can also give an example of, let's say, opening up a loaded file here. And so we've got little hello world text going along. We can, let's bring that back. Play a little animation of the hello world changing from one to another. And then, show them bouncing again, why not? And then it makes it a little bit more clear. Also, the frame rate goes way down, but that's, what you would expect. But you can see they're also upside down, but this is based on the shape that was submitted in the Atlas entry.
Yeah, I can see that now.
Yep.
So
Oh, and I do want to mention that I worked on this with Skytrees. It wasn't just me, but yeah.
yeah, well, this is a remarkably like complete Jam project. At least it has a ton of features, and it's like cool to see this idea explored so thoroughly. What kind of use cases do you imagine for this?
Yeah, so the initial use case that like kind of prompted at least the conversation that led Skytrees to ask me to do the Jam project with him was Dimitri and BMP in the Discord. We're talking about resizing text and how would you do that? And Dimitri mentions you would have like this SDF authored atlas of entries of primitives. And then BMP kind of like misconstrued it as being like the raster SDF, the MSDF type rendering. Then he like clarified, like, no, you would have primitives and they would be defined as such. And it just goes on. It's a very interesting conversation. And then during one of the fishbowls, there was like a live watching where I kind of like echoed that idea, started a conversation, and that's what prompted Sky to ask me about it. So yeah,
Well,
one
that's
of them
cool.
would be like font rendering. So this is not a great font. It was made in like, 10 minutes of just me messing around with very limited, like we have 3 primitives. Like, yeah, so hopefully in like future DLC extensions, you would want to have better support for that. Yeah,
Sure.
and yeah. So that would be one pretty interesting entry because everyone hates font rendering. It's a nightmare to do TTF and free type and whatnot.
Well, this is really cool. Um,
Thanks.
and I'd like to also sort of go a little bit deeper, if we have time, on the Atlas idea. So it's not just an SDF editor, which is itself an interesting thing that I haven't really seen done before, but it has this Atlas idea. What makes the Atlas component of this important?
Yeah, so I mentioned before that like if you just want to do SDFs, you can just write it in shader code. And then all it becomes is like, okay, well, bind that shader and then call that special SDF function. And then you get your SDF out at the end of the day. But when you make it with an atlas, then you can just say, hey, the CPU, all the CPU has to worry about is this is the index, right? And so then you can have like non-technical people who don't know HLSL or any shader language, write it inside the editor and then make it sort of fit to what they want. So I mentioned like you can go and then lerp the distances between them. Like say like world looks a little bit like high up there, so we can go over to world, select it, and then just sort of like, well, let's say like we drag it down a little bit there, and you can sort of edit it in sort of real time, hopefully, and you'd have even better tooling and better, yeah. Um, that aspect is something that I also wanted to have like that sort of fast turnaround time instead of like go into the editor, compile shader language, and then go back into the code, recompile and rebind, and yeah, just that visual turnaround time is what I really want.
Sure. Well, are there any questions from the chat before we move on to one of our demo videos? I'll give people just a brief window to think about that. And in the meantime, I guess I'll quickly ask, how did you enjoy the experience of working together on this one, teaming up? How do you feel like that changed the experience?
Yeah, it was really interesting. So this was like my first jam. So really having like here's what we're doing in the week. This is what I'm going to do, and this is what I think would really help, get these features out and keep like that end goal in mind. We had to like cut a lot of things for scope. Lots of cuts got made. It was really interesting, at least for me. Particularly like with the collaboration aspect, where Sky would just like ask like, hey, I want to be able to do this, or how should I do this? Does the SDF engine support that? I'm like, yeah, sure, we can add that in here, or like, no, that's gonna bloat the scope way out of proportion. Like having that like open dialogue and like that quick like, hey, I'm gonna be streaming in the Discord VC. Do you want to like join? That way we can talk things through. That whole aspect is it's really something.
Yeah. All right. Well, thank you very much for showing this off. Thank you, BYP and Skytreus, for putting together such a cool project. We're now going to go into the first of several demo videos that we have for you all. And this is actually what we're about to show a video of is one of the most complete projects that was submitted to this jam. It is, well, actually the author of it explains it quite well, so I will just cut right to the video. This is abbrv.
Hi, this is abbrv, a text expansion solution for the Windows operating system, meaning that all you have to do is type a few keystrokes, and the operating system will expand them out into an expansion that you, the user, have defined. It's very easy to add expansions and abbreviation pairs. Simple as hitting the Add New Abbreviation and Expansion Pair button, typing in what you would like to have as the abbreviation, and then typing what you'd like to see as the expansion. So if I type ping, Pong automatically appears in the Word document. It's saved automatically and live updated. There's no need to hit save or relaunch the program. You're ready to go all the time. You could do lots of fun things like maybe having a haiku at your disposal that you can drop into anything at a moment's notice. You can also use it to do things like maybe there's ASCII art that you're trying to insert on a page. So you could maybe insert an entire keyboard if you're writing documentation or trying to show the difference between a QWERTY and a Dvorak layout. A more practical application that I use all the time at work is for Google API keys that I need to insert into various programs for various clients. I don't remember the key off the top of my head. I have an abbreviation and expansion pair ready to go that automatically inserts it. Other practical uses, for example, are my Zoom meeting link. I always do that through an abbreviation because I can't be bothered to figure out where it lives in the Zoom UI to grab that code. I built abbrv because the existing solutions for Windows, as far as I could tell, were expensive, ranging from somewhere between $15 to $35 for something that I thought was fairly simple and not that demanding. They're fairly bloated. They come with a lot of additional functionality that I had no need for. And most importantly, probably, is that all of those solutions were closed source, and this functionality is quite literally a keylogger. I need to feel safe that my key presses are not being reported to some server somewhere and monitored for username and password analysis. So I think an open source solution for that is really important. I'm really pleased with the results. We had 1 week to build this. I think I got a 1.0 out the door that works really well. It fits my needs. It replaces the expensive closed source solution I was using up until this point. I've already deleted that program. I don't need it anymore. So I'm pleased with the results. In the future, I'd like to maybe support macOS, maybe do some Unicode support there. But that's it. abbrv is available right now. You can grab it from the GitHub page, which I'm sure there will be a link to. You can also just ping me on Discord and ask. Otherwise, it's jakemason/abbrv, ABBRV, and you can just grab it here from the release page. I'd like to give a special shout out to Martins for saving me on some of the Windows system tray woes and just giving me a lot of useful code snippets and advice there that saved me what I'm sure would have been hours of digging through the Windows documentation. Thank you.
All right. I hope you all enjoyed that demo. I think this is a fantastic project. We are now here with the authors of a project called Image Desk. And this is, in brief, an image organizer, and we're going to hear from 2 of the 4 authors who worked on this. And in fact, this team participated in last year's jam as well, I believe all 4 of them, and produced an alternative text editor, word processor kind of thing that had some really cool ideas and had really some amazing features in it. So in any case, they've come around again with a new project this year, and I'm excited to get that going. So we have Samuel and Enrique, and here's Image Desk.
Okay. Enrique, can you?
Okay, our first, how can I say, our first motivation for this project is that in general, when you have like, for example, those available image organizing softwares, they're either, only Apple compatible, or they're either like super heavy, for example, let's say Adobe things, or even if you get like an open source thing, they like generally like features, they're like super heavy. And because like, well, we like to take photographs, like to organize our photos, so we just came up with this software that it's able to render super like high resolution images, and we're really happy that it's like working quite well, so it's like super lightweight and everything. So yeah.
So basically, one of the problems we saw with current image organizers is they allow to organize images, sometimes even with artificial intelligence, machine learning, stuff like that, but they don't have a really good way to show you the images. So they usually have a grid pattern that you can, to see the image, you need to click, see full screen and stuff like that. So I decided to first do this kind of layout. It's a moving canvas. You can zoom in right to the image. They are full resolution right now. Probably in the current render, it cannot support many images, but this again. So the idea is that you have a canvas with possibly thousands of images, and you can just see in a understandable layout, and you can just zoom in right to the image. For example, here you have a full resolution image. I don't need to click on full screen or stuff like that. And to organize the image, I came up with a system of tags and filters. So basically, you can just create a new tag, tag an image with something. For example, this is, and they will be organized in these columns. And you can also create some filters. For example, this filter is every image with the draw or the space tag. Or for example, and this column is untagged images. So but I can, for example, I want to see all the travel images. You filter here, and the travel and draw images, or the travel and planet images. We use show buff, but you have also intersection. So you only show images the both tags. So for example, travel and space does nothing with both of the tags, but I can, for example, add, I don't know, the space tag here, and it will show up. And I can also save this as a filter.
Oh, I see.
So yes, and I can also, for example, filter one, or planet. I can put filters inside of filters, so I can also combine intersection and union. And I can also, for example, just let's see, for a good example, I can also exclude some text. For example, I have travel and space, but exclude the image with the draw tag. So the idea is to have full combinatories of every possible tag and filter. I think this is a decent way to do that. And also, since the idea is to do good visualization, we have, for example, a map.
Yeah. So may I say that a bit?
Yes.
So so basically, don't mind the rasterized map. We can like implement a vectorized version, like just a gem. But the things that, for example, some photo editors, I may say that our main inspiration was the iPhone photo editor. They group images from like the locations. And I personally feel that like a very super cool feature that, for example, there's one image organizing called Digicam. It also has like a similar feature, but it's like super bloated. It does not like just work straight like out of the box, and we just like wanted to have like a similar thing. So basically, our software grabs the EXIF data from the images and puts on a map. So to have this georeferencing image. Okay, so many images are in the no island because they're EXIF like 0, yeah, to zero coordinates, but don't mind that. We may just like exclude that. And like okay, this is like a little bit, let's say, not very useful right now, but we may, for example, establish some filters that, for example, group images based on location to make it easier, for example, to let's say, travel, let's say, to Barcelona, and then we like group all the images there, or Italy, or everything else. So that's the general idea.
The idea was to have many views. On design we only implemented the default view and the map view, but we could have many views. The idea is just, well, it's called image desk because you have many images like organized in a desk. So that is just, instead of just classifying the images with tags and stuff like that, we have a very simple tag system. It's not complex, but we experimented with the layout itself.
Yeah, and I find that very interesting because I hadn't really considered that the image organizing programs I've used in the past. I mean, I think you're right. They have not actually focused much on the experience of viewing the photos themselves. I mean, maybe like the iPhone stuff allows you to quickly browse to a photo and pull it up, but it doesn't have the sort of photo album, like the future photo album experience that you've got here.
Yes. Yeah, one simple thing, for example, usually it's in a grid pattern, and for example, this image would be in a box and bars on the side, so it not be full view. For example, I decided why not just fix the width, and since it's many columns, and change the height. So we are not wasting too much space with the images. And we can just zoom in right now and ProRes. You can hide this, and you can view your images like that.
That is really nice to see because I mean that sort of reminds me of actually, you know, taking a real photo album and just looking in closely at the photos instead of having to sort of navigate between files as I do it. That seems very natural.
And the software doesn't touch the file system; just index all the photos in a folder and just save some information. So it's not really touching the file system. Your image is still there. We did not implement any editing features for the game, but we could have in the future. We could do in the future. And one interesting thing about the project is Henrique takes a lot of photos. Most of these photos you see is he took the photos.
Oh, cool.
We have some James Webb telescope here, but most of the landscape and stuff like that is his images. And I don't take main photos, so I don't have a need for this. So he's the one who uses a lot of softwares. I never use an image organizer in my life, so we have this. I'm not, let's say, tainted with the current ideas, so I can think outside the box, and he knows what he needs for a software like that. So it's
sort of like
really
photo art here. So yeah, some photos.
Well, I myself have dearly missed Picasa ever since Picasa died. So, you know, I love seeing stuff like this that would like be useful not just to like professional photographers, but just to people who want to look at their photos. I really like. I think that is sorely missing in the world of today's software. So, I think this is fantastic. So,
we plan to continue this project. So let's see. I said that last year, but did not happen. Let's see. But
well, I hope you do. It seems like I mean, this is a fantastic result for a single week of work.
It's not that complicated of a problem. It's not that hard to do something like that. For example, last year I did the word process, and working with text is a pain. So that's why I never continued. But this is not a really difficult problem to solve. You just need to do. It's a lot of user interface stuff. It's not very complicated, and I think people can use it. We can create some value for people.
Yeah, definitely.
Awesome. Well, thank you so much for showing this off. If you want to look further into this project, Asaf has linked this project in the chat, as he has been doing with all of the projects so far. So please go check it out. The next thing. Oh yeah, sorry. Go ahead.
Discord really isn't doing this project justice. It's running really smoothly, and you can see a much smoother video on the project page.
Excellent. Well, then absolutely everybody should go check out the project page so that they can like really get a sense of what this program is about. All right. Thank you so much, both of you, for demoing, and all four of the members of your team for putting this together. It's really fantastic to see. The next thing that we have for everyone is a demo of a stream overlay system that one of our community members, Sully, has been working on. He recently added some features to it in the form of stream overlay. Oh, that's not the right layout at all. My apologies. He added webcam stuff to it this year, and we have a demo video showing all the recent features he's been doing. And I'm very sympathetic to this project now after spending hours wrangling OBS to prepare for this stream. So, Sully, take it away. All right, thank you so much, Sully, for that demo. Our next project is by Ginger Bill, the creator of the Odin programming language. And this is a project that, funny enough, we've been anticipating for over a year because he attempted it for last year's Wheel Reinvention Jam, but unfortunately got sick and wasn't able to pursue it. But he's back at it again this time, and he's got some cool stuff to show us. So welcome to the stream, Bill.
Hello, thank you for having me, Ben. Anyway, and thank you everyone here. So this year I was trying to reinvent the cookbook as well as last year, but unfortunately failed. But yeah, the whole point is that cookbooks in general, when you read them online or even in physical form like these, they always have there's kind of two issues to them. The first thing is you look at a recipe and you have to find out, okay, how much of these ingredients do I need? Okay, I have to look at what ingredients do I have and all that. And it's like, oh, so you've got this annoyance. Here's one second thing. Another second part is just finding out the unit. So if you read books from like different countries or different things, they'll use different units regardless and use them in different ways. So one thing that for me as an Englishman, I find really annoying when I read American stuff is they'll say like a stick of butter or a tablespoon of butter, or they'll say a cup of flour. And I'm like, okay, what's a stick of butter? I know it might be a standardized thing in America, but it's not here. So it's kind of a bit of these weird units. So one thing I would love was have some recipes, especially online recipes, was just to be able to change the units to whatever I want, and it knows everything about that ingredient, like the density and such. The second thing, which I didn't have time to finish to, but I will continue completing it, was the ability to have a reverse search. So hey, here's the ingredients I have in my fridge and how much I've got of them. What recipes and how many portions can I make from these recipes? So at the end of the day, both of these are actually completely linked, and they are actually just laying out the database problem. So let's just say that here's the software here. This is Project Ambrosia. We've got it in light mode, or we can do it in dark mode, obviously, because you have to have both. But yes, in general, you got these different recipes. So let's click on one of these recipes here. Maybe shall we do the ginger jam for this jam, which was okay. It's got details about the thing here, Ginger Bill. The source was Ginger Bill's Mind, live on stream. Different tags about this, the descriptions here saying it's perfect things like pork, chicken, or whitefish, and basic ingredients in here. So we can change the scale of how many we want to do. But notice you have all the units. So this is 8 ounces of stem ginger, 4 ounces of castor sugar, 4 fluid ounces of water, and 1 green chili. Maybe you don't know what ounces are, so let's just change it to grams. And does it exactly for you, knows what the conversions are, and it does the rounding as well. So we can get rid of the fractions if there's fractions there. Let's go to ounces. Let's say a pound. So this is a 1/4 pound of sugar. Maybe you didn't want that, but also it knows the density. So it goes, you know what? I want a cup. That's 2/3 of a cup. So you don't need to have to worry about any of that because it knows the density of what sugar is. Same with water and all that lot and any of the units. And you can scale it, and most of the steps are here. It even has the minutes and temperature ingredients on there as well. So I've got another example of this would be here. This has got some other units to it. This was directly taken out. Nigel also has How to Be a Domestic Goddess, because I can be a domestic goddess, the book in here. But again, this is written in grams, and I'm like, I think this is ounces. And if you do it, yes, it is. You can put more into ounces if we want. No problems. Okay, that was an ounce of butter. Let's do milk. Let's do, I know, just a few American viewers out there. So American fluid ounces, or an imperial pint, whatever, half an imperial pint. So there's all those things. So it's a nice way of doing things and showing all the units. And it's just really useful for me. You can convert every single unit in any different place with no issues whatsoever. So the plan for the next go on from this is to do the reverse. Now that I have all of the ingredients set up in the database, which is a big database here with all of the different stuff in it, things should go really easily and do all the fancy things, which is the searching abilities. So this is the forward cookbook. Next, do the reverse cookbook. Okay, any questions?
I want to pick your brain about the rounding stuff. Because
go ahead.
I know that there are many recipe sites that will do the conversion between imperial and metric units, but they always it's always primarily written in one unit and then translated to the other. And
yes,
for a lot of recipes, I mean, especially for just like cooking, not baking or something, it seems to give a false sense of precision. Like, you know, it'll come out to some decimal number of grams of sugar or of, you know, salt or chicken stock or whatever it happens to be, when it really like doesn't matter. So I'm curious how you approach the rounding in this. Is it like doing more than just sort of chopping decimals? Is it like sort of per ingredient, like does it have a sense of like how fussy that ingredient is?
So there's two aspects to it. The first thing is, as you see on those websites, they'll switch between let's say metric and then some other system, either the US system or whatever, but they'll be really bad. So not just that, they'll be seriously. Okay, so you got American cup, they'll cup. So when you convert it into English, or English or metric or whatever, it will do it as milliliters. So it'll tell you how many milliliters of flour that is. And I'm thinking, wait, I don't want to use so much. I want to know what the weight of that thing is. I weigh things on scales in this country, not in like. But even then, you do the wrong thing. So they're doing a conversion.
Well, that's not even a useful. Is that even like?
No.
That's not. If you wanted a volume measurement, that's not even a useful volume measurement, is it?
No, it's not. So these units are really bad, and they'll flip and change, and then they'll say like, "Oh, we're going to convert this. It's 7.368 ounces. That's what's what you wanted, right?" And you're like, could you just not round that to 7 or something, or 8? But so yeah, how I do the rounding on here is very basic at the moment, but because of the recipes I've done are basic. But the if I do, for instance, this, and go to this one here. This was 600 grams. I converted it to ounces, and it says 21 and an eighth. But if I get rid of the fractions, it just rounds it down to 21 there. So it's even getting to saying, no, this is really just 21. But some of them will even be, let's go to pounds in here, 2.25 pounds, or it's actually just 2.2 pounds. So it just it's trying to do the best estimate it can do
Sure.
by just not just per unit, but just like, okay, what's the error? What's the margin of error around the nearest whatever in there? And
Sure.
trying to get those there and trying to figure out like 30 grams isn't actually an ounce. An ounce is about 28, but it knows it's about 1. So it just round to 1.
Right.
It knows it's not that dumb. Like, oh, that's
certainly nobody needs to put 9/64ths of a potato into their stew or something.
No,
so
exactly. So it's just trying to find the rounding stuff in there and just trying to get those bits correct and just say, look, you've got to do it per thing, obviously, because someone was asking me, why don't you just have some like, oh, I want to convert to American always. I'm like, which American? Do you want cups? Do you want ounces? Do you want fluid ounces? Do you want like there are loads? Even in metric, you've got all the different ones as well to worry about. So it's not there's just one system to worry about anymore. It gets a little bit more complicated than that.
Yeah.
So that's why I wanted the flexibility.
Yeah, for sure. As for the so your aspirations are for the reverse stuff. Do you often find yourself just like with a fridge full of food and just looking to make some nice stuff?
It's usually the day before I'm going shopping. And I've got like some stuff random in the fridge, and I'm like, what can I make out of this? And usually I can figure something out, make it all up. But then it's sometimes like, no, I want to really use everything up. What can I make?
Sure.
And then I'm just scouring like my mind or books and going, I could do this be an idea, this is an idea. And like, oh, I haven't got this ingredient. Damn it, I don't want to go to the shop. I'm going that tomorrow or something. And it's like, it's really not, especially when I know people are on like budgets and such. It's like they just want to use everything up they can. Because you don't want to just go out, you're making a recipe like, oh, I don't have these ingredients. And then you go out and spend it. And unfortunately, you've had to buy a big bag of whatever, say cornmeal or something, when you only need a little bit. So you just wasted all that money.
Yeah.
And it's just annoying to me. And I guess so many other people. These products do exist, by the way. There are reverse cookbooks out there. They're all bad. Same with like the unit conversion thing.
Well, I was curious about that too, because this is definitely not like completely unexplored territory, but at the same time, every product I've seen like it gets something obviously wrong that makes me question whether these people have cooked at all. So
yeah, it makes me worried. It's like either have they cooked or are they only so used to their own way of cooking that like I don't care about the other people, just deal with them later on. It's a bit of a weird situation to be in, but yeah, I don't know why. So it's not a difficult problem. It's a database problem, so you have to know what databases are. So maybe that's the problem.
And for the reverse thing, you mentioned that you want to like, if you want to use stuff up, I mean, you're rarely going to have all the ingredients, but do you intend to have it sort of do it like you would almost have all the ingredients for this, or like you can?
Yeah, I'll try and do substitute for ingredients. I'll do approximate ingredients as also like, oh, you're missing this one, but you should be okay. Like it's optional or something.
Oh man, using substitute information in a reverse cookbook would be very powerful, wouldn't it?
Like a really good example of a substitute would be self-raising flour, would be just plain flour and baking soda.
Right. Huh. That's a really cool idea. Well.
So when are you accounting for altitude?
Oh man. You can use all the ingredients in your fridge much more precisely if you simply go up by a few thousand feet.
Yeah.
Well, you know, the temperature of your oven needs to change, right?
Yeah.
How long
I know. That's a funny idea.
Yeah, it's fun. I probably won't need to take that into account. That's the only thing. Only boiling that would care about, but yeah, you just look at it boil. Oh, it's boiling, done.
Well, thank you so much for showing this off, Bill. I look forward to seeing where this will go in the future. It's such a, I don't know. If you're not so I'm on Discord servers with Bill where I've seen him post food. He cooks a lot and he cooks good stuff, and I'm excited to see where he, how that food, that love of food shows up in these programs that he's making. So
Yeah. Well, thank you.
yes, thank you, Bill. So our next demo is a video of a Dreamcast disk burner. We're starting to go a little bit lower level now for a couple of our next projects, and so we have a project by Dan Boxer for burning Dreamcast discs. So here we go with that demo.
Hello, my name is Daniel Boxer, and for the Wheel Reinvention Jam, I decided to make a Dreamcast disk image burning program for macOS. To my knowledge, burning these disks can only really be done on Windows and Linux, I think. So I thought it'd be good to finally bring a solution to macOS. I was able to achieve some moderate success with this project, and I got some indie games and other small official games to burn successfully. However, I believe a vast majority of the library is currently not working. I hope to bring support for them in the future to this program. For this demo, I'm going to be burning the indie game Xenocrisis, released in 2019 for multiple platforms, including the Dreamcast, and show it playing on an actual Dreamcast. Okay, so let's start the burn. And pretty soon we'll see a progress indicator come up. Okay, perfect. So this is going to take a little bit, so let's let it do its thing, and we'll be back. Okay, great. Success. So let's now pop it into a Dreamcast. Once we see the Sega logo, we actually know that the burn worked, but let's let it get to the first screen in the game. And there we go. Thanks for watching, everyone.
Actually, exactly on time.
All right. Thank you so much for that demo, Dan. Oh, I'm on the wrong scene somehow. Hold on. There we are. All right. We are here with Alan Webster, one of two people who worked on a project called Lil UEFI for this jam. So this was Ryan Fleury and Alan Webster, both famously known around here for their work on Dion. That's probably the thing for which they're the most well known. And this is a really interesting project, and I'd rather not, jump the gun, say too much about it. So take it away, Alan.
Okay, so what we had originally been shooting for was to use the Jam Week as just an opportunity to get our feet wet with what writing operating systems looked like. And we actually did do that. I'll show real quick the operating system we wrote, but there's not a whole lot to see because that's not what we ended up actually doing. So here's the runnable operating system thing that we got. It's running in a I don't know how to pronounce this, QEMU emulator that gets a screen buffer and does a little changing color animation on it. And that's where we stopped on actually developing the operating system. And the reason for that was we knew we were going to do this, so we spent about a week before the jam just figuring out how to get the emulator set up and figuring out how to build this kind of program and link it and get all of those sort of details set up so we could just hit the ground running with the writing and operating system stuff. And in that week, we had help from Dan Boxer, who's the person who did the previous project we just saw the video from. He helped us because he's working on an operating system. And with all of that, we still had, our first day, we weren't sure how we were going to do it. And we just decided, Dan had suggested we try using Zig for it. And while that is fine and working for him, we didn't really know how the Zig build system worked. We decided, if we were going to try to figure out how to link Zig code and C code, and it was giving us a headache. So we thought, what does this look like if we just do it in pure C? And we found this this UEFI system. UEFI is the easiest way to sort of create the booting part of an operating system. And this was a set of headers that were pulled from a much bigger project. And these headers can be used to create UEFI applications, but also implement open source firmware or drivers for specific devices. They have a lot. It's got a lot of stuff in here. It's got a lot of different platforms in here. And trying to explore this code and figure out, like, if you go to uefi.h, it just refers you to more headers. You have to go track those down. And eventually, if you go far enough, you can find, like, okay, here are the base types. And we're seeing GUID and void. And okay, so that, the farther you go, the more you're like, I still don't know anything about this API. So we used this header library just to get ourselves up and running, and it took a little like fiddling with the build config. So after day one of the jam, we finally were building an operating system and having the colors change. And we thought, a week is such a long time. No wonder people don't do these kinds of projects more often. Why don't we switch our project to minimizing this headache for whoever does the next operating system jam project? So we switched over to looking at the UEFI spec itself. And this is a big spec, but it turns out that a lot of it is really simple. Like, if you take the time to get through enough of it, a lot of it just says, like, here's the type signature of the entry point. Here's, if I go far enough, we'll eventually start spotting like structs that just say, like, here's what structs need to look like. And so we thought, we could do this. We could build up our own header. So we had it building, and we decided to figure out what's the minimal amount of stuff we need to make our own header that would let us build our application as sort of an STB style single header experience. And we didn't quite end up there, but what we ended up with is this repo here, which has our example program with the changing colors and the Lil UEFI headers themselves. And it's not a single header because there are a lot of function tables. So we use this XList trick here to make the function tables easier to maintain. So you get the name of a function and the signature on each line rather than having to type def it in one spot and put function pointers in other places and get the layouts right in different places. So it's not quite a single header library just because we wanted to do that. But besides that, deviation from the normal rule, the entire UEFI that you need to build our program plus several other UEFI, like plenty other UEFI programs could already be built if you're just trying to build a UEFI application. So a UEFI application means the thing you write when you're trying to create an operating system, not the vendor-specific drivers or the firmware or anything like that. So if you're trying to make the operating system part, we decided you just drop our header in there and you should be good to go. There are some notes here about design decisions we made. We put in a little tiny example of like how to make a hello world that prints to the console. And it's got the ability to automatically figure out a lot of different architectures, not all of them. So if you need to put in your own integer types, you can do that. And then after all that, the rest of this is just hopefully as easy as possible definitions of UEFI. So the goal was that you'd start reading from right about here and go like, okay, well, if I go to table 5 back in the spec, I can see where all these ideas came from. And so you can start exploring here and go, okay, how do I begin? I guess system table. If you look at the example, you need an entry point that takes a system table. So you might figure out what the system table looks like from here and go, okay, I guess I'm interested in this con out thing. Where is this text output protocol? And that's just going to be a little bit later down in the same file. And again, the spec references are all the way throughout this header so that if you're interested, you can go read more documentation and details over here on this thing. We didn't want to clutter it up with lots of comments like this one did, right? Not that that was necessarily the wrong choice. It's just not our stylistic choice. It seems like we were having a hard time figuring out what anything was because there's so many documentation comments interspersed. So we just sort of did a repackaging of the UEFI headers to get to the point where you could drop in a single header and start learning UEFI on day 1 of your operating system jam project, not after 1 week of prep and day 2, which is what happened to us.
Yeah. That's crazy to me that the sort of just state of UEFI development would be so convoluted and difficult, especially when the spec lays everything out so straightforwardly.
Mm-hmm. Yeah, I mean, I was surprised by how easy it was to actually get this stuff working, because there's not actually anything to do if your goal is to create an operating system. Now, I think, well, part of the problem is that the only solutions out there are either deeply tied into like Linux specific headers, which are not, that's not what this one is. Or it's this one over here, which is like an open source project that is trying to simultaneously serve like 5 different kinds of use cases or whatever. And so if you had this more narrow use case that we had in mind, and you didn't know like all the, you don't have a complex build system, you kind of just want to drop in, get it working, no one's taken the time to just package it that way. And a lot of times I think things that look huge look intimidating, but it's usually the case that you can refine something like this down to it's just a bunch of type definitions. What we have actually offered has no implementation at all, and yet I think it'll make this process easier for anyone who gets started now.
Well, it sure looked like it. So I was looking at the example code that you had before and was amazed by how short it is. I mean, I expect anything related to booting an operating system anything related to booting an operating system to be weird and arcane and probably have all the like hundreds of lines of setup like I expect from, I don't know, graphics APIs or whatever it is. But like, this was not that. It looked very, very straightforward.
No, yeah, UEFI is pretty high level. So one cool thing about it is it's almost like an operating system API, except that it doesn't have, a real operating system underneath. It's a rather lightweight implementation that is provided under the hood. But that's stuff that the hardware people are going to provide for you. So if your goal is to learn about writing an operating system, you don't need to go learn all the device protocols just to get some of the basics up and running. I think to make a hardcore operating system, you would eventually want to redo everything UEFI had done in a more hardcore way. And then you would have like, well, we got to configure CPUs in a specific way. And we got to learn how to speak this protocol or that protocol. But UEFI is supposed to make this very simple. And when you look at what actually has to be done, it's like grab a function, like a table pointer, call a function. Now you have a string on the screen. It's almost like using anything as simple as like SDL or whatever else, except it doesn't actually have sprites built in. But besides that, it's like ready to go if you wanted to do graphics or console input output. I think Ryan even went and implemented. Let's see here. I think he did the USB protocol in here, so you could start talking to USB devices. I think he did my mouse input as well. But yeah, there's plenty. By the way, if you look here, this is slow work, so there's a lot of spots where we were like, hey, in the future, if someone's writing something that needs this part of the spec, here's where it would go.
Right.
So hopefully, if you do start using this and it isn't enough, it would be very easy to extend to just put in like, oh, well, section 19 stuff would go here and contribute that back. Hopefully follow the same style of like the X lists and the putting in comments for where things come from in the spec. But besides that, it's pretty easy to extend with whatever you need. There's a lot in there, obviously.
Yeah. So is it the case these days that like, so I was chatting with Ryan on his stream the other day, and he mentioned that it seemed like Zig was sort of the recommendation for the time being because, so I guess I'm curious sort of what the current state of UEFI development looks like with regards to that, because I know that Dan has been making his own operating system in Zig, and like, what does Zig do to address these same kinds of problems? Because it looks like they're doing something at least somewhat better than the status quo.
Yes, absolutely. So Zig has the huge advantage to Zig is that the standard library just has a UEFI implementation. Like all of these headers are basically in there, along with a few like helper functions and stuff that they added. So if you wanted to use Zig and you were going to like really learn the project, which I think for us it would have taken more than the jam time to fully figure out like how to build. We were hoping to write the operating system half in C and just use Zig to get the like booting part finished and then be done with it. And when we were looking at what it actually takes to boot, it was fairly simple. So the Zig thing is kind of similar to what our header is, except I think they've probably covered more of the spec already.
Sure. Well, I presume they've had more than a week.
Yeah. But besides that, that's all it is. I mean, we're really just talking about if you know the right layouts and the right function signatures, you can write the application side. So they have specific stuff that's in the standard library already. So if you want to write a UEFI application, you basically are just marking that in the build, Zig build, that this is going to be for UEFI, and then it'll link everything correctly into the right kind of, you're not building a .exe file, you're building a .EFI file, but it's the same concept, sections of code and data and entry point and stuff like that. And so they've got that built into the building and to the standard libraries. You don't need to get anything extra. For us, the main reason we didn't want to go with Zig was just we were hoping to do everything in C, and on the C side, it was quite a bit more work than that to get up and running.
Yeah. Well, I wish that I could keep talking about this, but we do unfortunately have to move on to other demos. Huge props to you and Ryan for taking this on. I mean, even just the ambition to do operating system stuff for a jam project. That's like a running theme with these handmade network jams, and I love it. And in fact, with stuff like this now in existence, it makes me really want to do like a deliberate OS jam to get more people into that stuff, especially since it appears to be like higher level and easier to use than like a lot of the actual normal software we're writing.
Yeah.
So that would be such a cool direction to explore in the future. And thank you to you and Ryan for putting in the work on that.
Thanks for doing the jam.
Yeah. All right, we are going to go to another demo video now. We're going to start looking at a couple projects that explore programming tools themselves. And we're going to start with a video by Kartik Agaram on a project called Bifold Text.
I like debug by print. I use debuggers occasionally, but I've never understood why so much engineering effort gets expended for the sorts of interactivity they provide. Interactivity which encourages complex sequences of breakpoints for any real-world session. Enable breakpoint A, wait until it's hit, then disable it and enable B, and so on. At the end of all that setup, I constantly find I hit step once too often and now have to restart the sequence all over again. There is no undo. Debug by print sacrifices interactivity for the ability to lay out changes over time. You do have to take greater control over the debug experience, what you choose to print out and when, designing the copy of the log to be clear. So that's issue one. We'd like to be able to script debugging flows. A second issue with both approaches is that they don't encourage us to share our debugging workflows with our collaborators. Debugger settings are lost when you exit. Debug prints are usually deleted before making a PR. Casey Muratori's demo of the Mustache tool shows the value of saving information between sessions. Let's do more of that. A third issue both debuggers and prints share is an over-reliance on text. The graphical debugger DDD is better than most debuggers at showing pointer relationships, but it's still too hard to get it to make your data look the way you imagine it in your head. And the graphics can't be tailored to your domain. It can't render a list embedded in the array it contains metadata for example. So that's the three major issues I tried to address in this year's jam. And I wanted to do it in a simple way that keeps the programmer in control so you can tailor it further to your needs. Let's see how. Debug prints naturally live in source code. What if we had an editor that could hide them by default and show them on demand? Then we wouldn't need to delete them from our PRs. Similarly, what if you could specify how the debug environment should render different objects in your program? The natural way to do that is also as first-class source code in your program. Putting these ideas together, we end up with a debugger that's not very much code at all, just the ability to selectively hide text and a set of hooks for appending pictures to a hierarchy of sections. There's a few different directions we could take this. First, support hiding debug prints in other tools. Git diff is an obvious first candidate. Second, Though I tend to think debuggers overemphasize performance concerns that don't matter for the vast majority of situations, performance is still worth thinking about. But I wouldn't come up with tricks to speed up debug prints. Instead, I'm imagining some sort of declarative configuration language, maybe a print_rc, ignore prints in these functions, drop prints under some level of call depth, expand everything in function A, and so on.
All right. Thank you so much, Kartik, for that video. It's such a cool project and like subtle in how it adds just a little, but also requires you to sort of rethink the very format of source code to get there. It's a really cool little project, and I'm so curious to see where it takes it. So our next project that we're demoing is a project called Cork. This is a project taking on decompiling. This is by a community member who is in fact also making compilers and compiler backends. If you hang out in any voice channels on Handmade Network, you know his name. It's Negate, and he is here to demo Cork.
Hello. So yeah, not sure what I'm supposed to do, but essentially I spent my Reinvention Jam just slapping together a decompiler because I was unhappy with Ghidra a long time ago, and that came to mind when I was going through the whole reinvention ideas, I guess. So the first thing I started with was basically just slapping together a window that would be able to take in object files based off of some source files. And so the idea is that I've got these compiled out into object files. It technically works as executables, but it's iffy. And so if I were to drag one of these in, it would actually show me a visualization of what's going on over here. And so what I can do is I could actually, I can't resize this window. That's unfortunate. Let me actually start renaming some of these variables to, actually I'm not going to name it that. And then, yeah, essentially, I can actually rename the variables such that I can have a better image of what's going on in the code. I can do this with other demos too. I only got so many features in, but
So
I like to believe it's enough of a decompiler.
Are you rebuilding from assembly there, like or bytecode, I guess, from the actual binary? Or are you doing?
Yeah, so I go through. I go from assembly, I disassemble it, convert that into an IR, and then take that IR and start doing some analysis on it to find loops, to find branches, and then I get back something that looks semi-structured.
Yeah. That's crazy that you managed to do that in a week, man.
Yeah, no, there's still so much left, but it's definitely showable, which is the helpful part.
Just that's impressive.
Thank you.
It's not a small feat. So I guess the real place I'd love to focus. What don't you like about existing decompilers? Why did you want to reinvent them?
So one of the things I didn't like was, first of all, there's the surface level stuff. So first of all, they look ugly and they are slow. The other ones are just that in terms of tooling around deducing certain things, I wanted to improve on that whole scenario.
Sure.
And so this is something I never got into in the whole jam because unfortunately I didn't have time. But essentially, I wanted to get into analyzing the call graph. So, main calls, foo, bar, and baz, and then showing that to the user. And so there's certain spots where I can't figure out what a function call looks like just because it's got a weird prototype. And so an example is varargs. Varargs just has a variable number of arguments.
Mm-hmm.
And so this is a part where the user would fill in the type and something like Ghidra or Ida and be like, oh, this is varargs, because they might be able to spot it and the computer might not be able to.
Sure.
But when it comes to certain other types, so like virtual calls, generally we have a vision of what the prototype looks like. We just don't know what we're calling. And so there's it would be very nice if you could just like deduce based off of what compatible functions there are in the code base, what could be called from this. Because there's only generally so many things that get called from a virtual call. It's usually like in a C++ code base, it'd be whatever is like actually a virtual call of some class. And being able to filter by that data would be very nice.
Sure. So I noticed when you hover over things in your decompiler, it looks like was it doing grouping as well, or is it? Yeah.
Yeah, it does do grouping.
That's pretty good. So how is it doing that? Are you figuring out what like a rough AST looks like? Like,
yeah, so this is actually, it's all in like a structured form right now. And
Okay.
so what I do is I just convert it into a text form, and then I like write down where certain boxes are for like expressions.
Sure. Okay.
Yeah.
Well, I guess that makes sense for some of those things. Like adds and compares are pretty straightforward. That's really cool, man. Just the fact that you got this far is in a week is crazy impressive.
Yeah, thank you.
So why pink? It just like really stands out.
It was a color. I didn't try a color picker. It was just there.
No, it's very visibly obvious.
Yeah.
Like
Can I ask about the name? So it's named Cork, and the project description talks about sort of a magic cork board. And I mean, obviously, it sounds like the actual task of decompiling, which I mean is enormous. Maybe got in the way of some of the UI ideas. But I'm curious if you could like describe some of the UI that you envisioned for this.
I actually just envisioned a giant corkboard. You could load like functions into it and then just start poking at them. Basically, I never got around to like slapping a corkboard texture on this thing or setting up multiple functions. So once I do that, it will definitely look nicer.
Are you using that disassembler that the disassembler that you're working on a couple months ago?
Yeah, actually.
Sweet, man.
It's crazy to me that you are building compilers, decompilers, compiler backends, disassemblers, like everything related to all aspects of. I mean, when's the linker, right?
The linker is actually very soon. I really want to do linkers.
I am absolutely looking forward to that. In fact, Colin was just looking at some trace viewer stuff yesterday and looking at traces from Quick, which, if you don't know, is Negate's C compiler, and half the time was spent in linking, and it just looks very like big and sad, just one long line of linking. So this is super impressive. Like it for those who don't, like when you just look at it, it might not look that impressive, I guess, because it looks like just a simple little function. But like the amount of technical work you have to do to get here is incredible. So I think it's amazing, that you were able to achieve so much in a week, and it really like gets me excited about where you might be able to go in 2 weeks or more.
Like the disassembler alone, I mean, Negate and I banged our heads on it for at least a couple of weeks straight after tossing in an original attempts, right?
Yeah.
So it's a lot of pieces that kind of built up to this, but it's really crazy. Well, thank you for such an awesome contribution. I want to see more from Cork and Quick and TB.
The whole Negate ecosystem.
Absolutely.
Yeah. All right. Well, thank you so much. So we don't have another demo video right now. But what we're going to go straight into our final interview of this stream. It's one that I'm personally quite excited about. So this is a project that is, relevant to my interests. It's very close to my own expertise and sort of the kinds of problems that I've wanted to tackle for a long time, and I'm glad that we're finally starting to see some progress on them. So this project is described as a launcher for applications based on WebAssembly. When you look at it, I think that it might remind you of something familiar. So I'm going to hop back over to the main stream now, where Martin Fuyela is going to demo Orca.
Hi. Let me share my screen. Okay, that's it. Okay. Okay, so my project is called Orca, and so it's a launcher and a standalone runtime environment for WebAssembly-based application. And we can maybe go later into motivations behind it, but for now, let's just say that I wanted a platform that gives some benefits of web applications and like easily distributing and getting applications cross-platform format and running them in Sandbox. And I wanted a platform that does that without like carrying all the weight of the browser, JavaScript ecosystem, DOM, etc. Basically the whole web tech stack. And I also wanted to let you have some like a local library of application that you can use offline, which you can't do with normal WebAssembly application. So let me show you the app. Okay, so here you have the launcher and a local application library with a bunch of dummy apps for testing purpose. And you can select an application and you can see banner, description of what it does. And you can double click applications and open them in a new tab. And it's all the same application form. So yeah, you can close down. Okay, and now thing you can do, whoops, is that it doesn't play well with video capture, I guess.
Oh, wow.
Yeah.
Well, I mean, at least one of them,
the
the triangle example from before worked at least, so there's that.
Yeah. Wow. So I'm trying to show you how you would launch an application, like a website, if it works. We will see. So, yeah, I think my whole computer is lagging like crazy.
No worries.
The video. Yeah, sure. Okay, so when Firefox will open.
Yeah, believe me, I know this pain. Macs, for some reason, really struggle to do Discord video sharing stuff. I don't know why it's so bad, but it is.
Yeah.
Yeah, I don't know about maybe we can try that. Maybe quickly.
If need be, I can pull up some of the demo materials that you've put together on the Jam page, and we can just discuss them there. But I hope that we can show the demo live. We're a little bit ahead of schedule here, I think. So
yeah. Obviously, it was working in the pre-stream.
Of course, that's just how this works.
So let's see. Yeah.
Looks good, maybe.
There. Sure. Yeah, so basically you would go to the web page of the developer that distributes Orca compatible applications, and it's just a web page with a link that you would click, and it asks you if you want to open the link, and it automatically opens the launcher and hopefully runs the application. I'm not very confident This
Well,
one.
yeah, I know that you do have pre-recorded video of this working, so I can pull that up if this doesn't work.
Burner. Yeah.
Oh.
It's good. It's just
Oh.
slow.
Yeah, it's just like lagging my.
Hey, look at that.
I know. Really what I hoped, but in terms of graphics and responsiveness, maybe you can show some of the videos I made previously where I don't have this
Yeah.
problem.
I can do that in a little bit. Let me.
Should be better.
Yeah. Give me just a moment to like add the thing to this scene. It's not something that I quite had prepped, but I do have the actual browser capture prepped. So sorry. One moment.
Yeah. I have prepped something because like last year for my Jam project, we also had problems with video capture.
Yeah, there. It's like no one could ever tell. All right. So yes, which aspects of it would you like to talk about? Do you want to go through that demo again of launching apps from the browser? Because I can just play that video here. So I mean, I have to say, this is like an incredible. You realize that in a week, you have essentially done a whole proof of concept of what a future browser could be. That is so crazy to see. I mean, even down to the sort of transition plan where using an existing browser, you can. Oh, your audio is cutting out. I'm sorry.
Well, so that's a little workaround because, sorry.
You're good now, I guess.
Can you hear me?
Yep, we can hear you.
Yep. So yeah, eventually the place you have something to allow you to browse applications and to find new applications. Right now we don't have that, so there's that little workaround where you can put a link with a special protocol that's like Orca :/ and then URL to a zipped bundle application, and the link will automatically open the launcher, download the application in a temporary folder, and compress it, and then run it in a new tab. So that's kind of a workaround. In the meantime, when we don't have yet a way to browse applications on the web.
Right.
So what's in the actual payload? What is Orca loading?
So, well, I could show you, but I won't share my screen again. Well, Orca just looks at application bundles in a local folder, and each application bundle is just a directory with a specific structure, and inside it you have like a directory which is a local file system for all the application. You have a directory which contains the WebAssembly module, and you have a resource directory which contains icons and the banner and some description of the application. And you can also put additional resources there if you want to use like images or things like that. So it's pretty easy to just package your WebAssembly module with some icon and zip it and put it online and put a link to that on the website. And what I also wanted to show is that normally the app you download from the web are executed in a transient way, meaning they don't show up in your local library and they get deleted once you close them. But you have the option to cache the apps. They get transferred to your local library and they are non-persistent. So you can use them offline. And you can also just upgrade your application by just going back to the same link, downloading the application again, and it will ask you if you want to overwrite the So yeah, you can sort of build your own library like that.
That's amazing. This is just so amazing to see, because like I mentioned in sort of my intro, ever since I came into this community years ago, there has been all this talk about, the web and how much of a problem the web is and what should we do about the web and when are we going to turn our collective handmade attention to the web. And it's always, it's a really daunting thing. It is seeming like it has so much momentum. Browsers are so large. It's a very scary challenge, and it's one that's easy to shy away from. But now in a week, you've just put together like a prototype of what it could look like. It's using, I guess, what we might consider the good parts of what are in browsers now. I mean, I guess we could talk about the merits of WebAssembly on its own, but it sure seems to have worked well for this use case.
Yeah, at least it's a sane part that can be separated from the rest of the web, and you don't have to pull the whole stack. And one of the difficulties in the discussions about the web is that like the web is not one thing, and everybody has its own angle and its own take on what the web is and what part of the web we should reinvent. So trying to content everybody is bound to recreate the same kind of browser that does everything. So this kind of application is admittedly very limited. There's not much you can do. But as I try to argue in my post I made for the project submission, I think the way the browser and the web is layered is kind of backwards. And with this project, I was trying to just flip the stack upside down and just have an execution model, an app distribution model, where you can just get applications, cross-platform applications, and run them in Sandbox. And that's your base. And then you build the rest of the web on top of that, instead of doing what we're doing now, which is building applications on top of a document model that's completely inadequate and that was not meant to do that.
Right. Well, and you can even see this sort of the way that this could even like there's always the social problem of getting users, but you can see how this is not far off from what we see with Electron or whatever today. This is kind of the same concept. You have a simple little runtime that you can have on every platform, and then you distribute the apps. And at the moment, what you have has a little bit of an install step, but like not even that bad, because it's just click a link, like it's a one-click install.
Yeah, you have the first install. You must install the application, but that's like any browser you could install. And it's not rare to have like web applications that require you to download Chrome or a new version of Chrome. So you have to download a browser anyway. And then there's the temporary workaround to just get a link. It gets runs automatically, and you can install if you want, but you can also just use the application, close the tab, it gets deleted. So it's kind of like using a web application in a browser.
Yeah. Well, Colin and I, when we did our Jam project, ours was built in WebAssembly, and I suspect it would not really take much to replace the basic shape drawing functions we were doing to target this. And like that would be such an amazing proof of concept to just like see which features are important to add next and just see how it feels. It's amazing to just go from being afraid of the enormous complexity of the browser to having essentially a prototype browser in 1 week. I mean, it's just absolutely fantastic.
A very cut down one with very few features, but yeah. And basically, like right now, you can draw using WebGL or GLES, and but I want also to expose the Canvas drawing API that I'm using to draw the rest of the UI. So it's just exposing those functions to to the
Yeah.
WebAssembly program. And you can either use GLES or use some simple vector 2D vector graphics stuff, and you can start drawing some shapes right away.
Yeah.
Well, I wrote another fun WebAssembly thing yesterday, which I think would also be an interesting one to stick on top of Orca. So we've got 2 apps already, right?
Yeah, we're gonna be knocking on your door here.
We've got a network simulator, a flame graph tracing tool. We're already in shape.
Yeah, I try to make sure it works with demoing and
Yeah.
live capture.
No worries about that. Again, everybody can go look at the project page via the link that Asaf shared out. You can see all the videos there, the full rationale behind Martin's approach to this design problem. And am I right? Did you even have a download of it that people could use if they were on Mac?
Not right now.
Oh, okay. Sorry.
But I try to put one.
Sure thing.
I hope to continue to work on that project. So.
All right. Well, thank you so much for this demo. It's absolutely fantastic.
Thanks for having me.
Yeah, and that wraps up everything that we wanted to share today. So, to go back now to just sort of some closing words. This was an absolutely fantastic time. This jam was I'm so happy to be part of this community and so happy to do these jams on a regular basis. It's amazing to see what this community can produce when we give them an excuse to just chase an idea. I love doing this. I look forward to doing many more of these in the future. Maybe even more often if there's interest. There's been discussion of that, and I would absolutely be happy to push for more jams as well. So, and I would also like to, before we get into sort of our closing business, this jam already produced one pretty complete project in the form of abbrv, and in fact, Asaf, who has been sharing the links in the chat this entire time, has been using abbrv to post those links in the chat. He had them all queued up, ready to go, and was able to bang them out without having to copy paste them from anywhere. So this jam, it already has produced useful software that we're all able to just use today. So to everybody who worked on projects for this jam, regardless of how well they turned out in your mind, whether you feel it was a success or whether it didn't go as you expect, I really encourage you to keep working on them. It's in 1 week we've seen so many ideas, so many prototypes, so much stuff learned, and even the things that aren't in your mind a smashing success are still like an enormously valuable thing to guide your work on that problem in the future. So you all, of course, already have handmade network projects set up and created that you can continue sharing content on. You can continue sharing stuff in Project Showcase. You can continue sharing things directly from the website. If you are still interested in the ideas that you've been working on for this jam, please keep working on them. I'm so excited to see where these projects can go in the future. So the last order of business that I think we have before we sign off for the day is we want to encourage you all to, where is it? One moment. I had not put my mic in that scene. My apologies. Go sign up for Handmade Seattle. So there are going to be many more projects like the ones that you saw today demoed at Handmade Seattle. Handmade Seattle is the conference run by Abner Coimbre, the founder of Handmade Network. It is a completely independent conference where he does not take money from corporate sponsors. The corporate sponsors do not have any influence in, the speakers that he hosts or the stuff that he talks about. You can attend either in person or online. Abner has worked very hard to make it a compelling experience for both in-person and remote attendees. And in fact, this year, online attendees gain access to job booths and recruiters as well, in addition to the private Q&A server where conference goers can ask questions of the speakers. It's a special perk, and the conference is extremely inexpensive. If you've seen conference prices for your average run-of-the-mill software conference, it is way more expensive, and you get a lot less out of it. So please go support Abner and look forward to seeing more of these projects in the future. And even if you don't have the money to pay for a ticket, the conference is streamed online for free. So watch this space around November 16th, from November 16th to 18th. That will be happening. Please go sign up, support Abner, and support amazing projects like the ones you saw today. So with that, Asaf, Colin, do you have any other closing words or thoughts?
Well, thank you all for participating in the jam. It's been amazing. See you next jam.
All right. And with that, we'll sign off. Thank you so much, everybody. And we will see you around on the Discord and on the website and just all across the community and all the projects everyone's working on. So see you next time.